Hello dear students, all of you welcome to Vidyan classes. Today we will discuss area of a triangle in determinant form, condition of collinear and problem discussion on concepts of lecture number 1. First, area of a triangle. Let A x1 y1, B x2 y2 order pair and C x3 y3 order pair be the vertices of the triangle ABC. A x1 y1, B x2 y2 and C x3 y3 be the vertices of the triangle ABC. In plane coordinate geometry, in plane coordinate geometry, that is 2D, two-dimensional coordinate geometry, or on R square, in plane coordinate geometry or two-dimensional coordinate geometry or geometry on R square, we have read the area of the triangle ABC is del given by half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. In plane coordinate geometry, we have read the area of the triangle which is denoted by del is given by half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, which is same as half of x1 y2 minus y3 minus x2 y1 minus y3 plus x3 y1 minus y2. Taking minus sign, here we get minus x2 into y1 minus y3, which is same as determinant of half of determinant x1 x2 x3 y1 y2 y3 1 1 1. expanding along row 1. Expanding the first row, we have x1 into y2 minus y3 minus x2 y1 minus y3 y1 minus y3, and its sign is positive, plus x3 into y1 minus y2. Expanding this determinant, we will get this result, or this is the same as this. So area of the triangle is given by this. In determinant form, it takes this form. Clear? It is the determinant form of area of a triangle whose vertices are a x1 y1, b x2 y2, and c x3 y3. It is the form of in coordinate geometry. In 11th class we have studied the area of the triangle is given by this. It takes the determinant form as half of x1 x2 x3 y1 y2 y3 and 1 1 1. It is the determinant form, it is the coordinate form of the area of the triangle. Clear? Clear? Okay, next, condition of a collinear. Condition of collinear. Let capital L be the line. It is the point having coordinates a x1 y1, b x2 y2, c x3 y3. Capital L is a line on which a x1 y1, b x2 y2, and c x3 y3 lies on the line capital L. 3 points is said to be collinear if they lies on a line. Let a x1 y1, b x2 y2, and c x3 y3 lies on the line L, that is capital A, capital B, and capital C are collinear. 3 points are said to be collinear if they lies on a line. Since the points are collinear, implies the area of the triangle ABC is 0, which implies area of the triangle is denoted by del, implies del is equal to 0, which implies half of determinant x1, x2, x3, y1, y2, y3, 1, 1, 1. It is the determinant form of the area of a triangle. It is the determinant form of the area of a triangle, which is equal to 0. Implies determinant having elements x1, x2, x3, y1, y2, y3, 1, 1, 1 is equal to 0. Is the condition that the points x1, y1, x2, y2 and x3, y3 are collinear. That means the 3 points lies on a line. Clear? Clear? Okay. Not if del less than 0. Del means area of the triangle. If del less than 0, that means area of the triangle is negative, then if del less than 0, then the area of the triangle will be mod of del, which is greater than 0. If area of the triangle is negative, then area of the triangle will be modulus of del. That means if del less than 0, mod of del greater than 0. As area always positive. Clear? Area is always positive. If on calculation, if del is negative, if this result is negative, then we will take its modulus as area of a area always positive. If del less than 0, then area of the triangle will be modulus of this. If del is minus 2, then its area will be modulus of minus 2 is plus 2 square unit. Clear? In 11th class we have studied in plane coordinate geometry. If A x1 y1, B x2 y2, C x3 y3 are the vertices of a triangle, then area of the triangle is given by half of x1 into y2 minus y3 plus x2 y3 minus y1 plus x3 into y1 minus y2. Taking minus sign here, it gives x1 into y2 minus y3 minus x2 y1 minus y3 plus x3 into y1 minus y2. Expanding this determinant along first row, That means its sign is positive, it is negative, it is positive. X1 into y2 minus y3 minus x2 y1 minus y3 plus x3 y1 minus y2. Clear? If the points are collinear, then area of the triangle is 0. So determinant del is equal to 0, which implies this result is equal to 0, which implies this result is equal to 0. Is the condition that the points x1, y1, x2, y2 and x3, y3 are collinear. Area is always positive, that means del always positive. If del is negative, then the area of the triangle will be modulus of del. If del is negative, which gives the positive, as area always positive. Clear? Okay. Write down. NCERT book, page number 122, part 1, exercise 4.3. Question number 4, first bit. Find equation of line joining 1-2 order pair and 3-6 order pair using determinant. Find the equation of the line. Let Pxy be a point on the line joining 1-2 order pair and 3-6 order pair using determinant. Let Pxy order pair be any point on the line joining A 1-2 order pair and B 3-6 order pair, which implies this. Since P lies on the line joining A and B, the 3 points A, P and B are collinear. Implies this. The points A, P and B are collinear. Clear? Since A, P and B lies on a line, implies this, the points are collinear, which implies this area of the triangle APB, which is equal to del, is equal to 0, which implies this half of x1, x2, x3, y1, y2, y3, 1, 1 and 1 is equal to 0. Since the points are collinear, area of the triangle is 0. Let x1, y1 is equal to 1-2 order pair, x2, y2 order pair is equal to xy and x3 y3 order pair is equal to 3 6 order pair, which implies this half of this equal to 0 or this determinant is equal to 0, which implies this x1 x2 x3 x1 x2 x3, that is 1x and 3, 1x and 3, y1 y2 y3, it gives 2y and 6, 2y6, 1 1 and 1, which is equal to 0. By the cross multiplication, 2 into 0 is equal to 0. Expanding along row 1, it gives 1 into expanding along row 1, 1 into y into 1, that is equal to y minus 6, 1 into 6, minus x, the sign of x is minus, into deleting the corresponding row and a column, the determinant obtained 2 6 1 1, which gives 2 minus 6. The sign of 3 is positive. Deleting the corresponding row and the column, it gives the determinant having elements 2 y 1 1. It gives 2 into 1, that is equal to 2 minus y, which is equal to 0, which implies this y minus 6 minus 2x minus plus 6x plus 6 minus 3y is equal to 0. 6 is cancelled, which implies this 6x minus 2x, that is 4x minus 2y is equal to 0. Y minus 3y equal to 0, which implies this y is equal to 2x. This is the equation of a line. Find the equation line joining this and this using determinant. P, X, Y is any point on the line. Since A, P, B are collinear, the area of the triangle is 0. Expanding along row 1, it gives y is equal to 2x is the equation of line. Clear? Okay. Next, if area of a triangle is 35 square unit with vertices 2 minus 6 order pair, 5 4 order pair, k 4 order pair, then k is dash. Let A is equal to x1 y1, which is equal to 2 minus 6, B is equal to x2 y2 is equal to I4 and C is equal to x3 y3 order pair which is equal to K4 order pair. Area of the triangle is 35. Area of the triangle ABC which is taken as del is equal to half of determinant x1, x2, x3, y1, y2, y3, 1, 1, and 1, which is same as half of x1, y1, 2 minus 6 order pair, x2, y2, 5, 4 order pair, x3, y3, k4 order pair. It gives 2, 5, k. x1, 2, x2, 5, x3, k. y1, y2, y3 minus 6, 4 and 4. 1, 1, 1 which is equal to half of expanding along row 1. It gives expanding along row 1. 2 into 4 into 1, 4 minus 4 into 1 that is equal to 4 minus 5. Since sin of 5 is minus 5, deleting the corresponding row and the column, it gives minus 6, 4, 1, 1. Minus 6 into 1 that is equal to minus 6, 4 into 1 that is equal to minus 4. The sign of k is positive, k into deleting the corresponding row and the column of k, it gives minus 6 into 1 that is minus 6, 4 into 1 that is equal to minus 4, which is equal to half of, it is 0, 4 minus 4, 0, minus 10 into 5 that is 50, minus 10k, which is equal to half of 50 minus 10k. Given area of the triangle is 35 square unit. Given area of triangle del is equal to 35 square units, which implies 35 is equal to half of 50 minus 10k modulus, which is equal to del. Del is the area of the triangle. Area of the triangle is 35. Since area is always positive, since del is equal to area of triangle must be positive. 50 minus 10k. 50 minus 10k may be positive or negative, so we will take modulus of 50 minus 10k is equal to 35, which implies yes, 70 is equal to mod of 50 minus 10k. 35 is the area of the triangle. So the right hand side must be positive. So we will take modulus of half into 50 minus 10k, which implies yes, 70 is equal to 50 minus 10k. Or 50 minus 10k greater than 0, which implies yes, 10k is equal to minus 20. That implies 10k is equal to minus 20, which implies yes, k is equal to minus 2. And 70 is equal to, it is a star. It is taken as a star. 70 is equal to minus of 50 minus 10k. For 50 minus 10k less than 0. It gives, star gives two results. If it is positive, then 70 is equal to 50 minus 10k. If 50 minus 10k is negative, it gives minus 50 minus 10k. Since x mod is equal to x, if x greater than equal to 0, and minus x if x less than 0. If 50 minus 10k is positive, then 35 is equal to half of 50 minus 10k. If 50 minus 10k is negative, then 35 is equal to half of minus 50 minus 10k. Minus of 50 minus 10k. Since mod of x is equal to x, if x greater than equal to 0, minus x if x less than 0, it is the definition of modulus function, which implies yes, 10k is equal to 120, implies yes, k is equal to 12. Clear? Therefore, k is equal to, there is two values of k is equal to minus 2 or 12. So the correct option is D. So the correct option is D. It is minus 2 or 12. So that the area of the triangle will be 35 square units. Clear? Okay. Write down. Next, NCERT book, page number 108, part 1, exercise 4.1. First note, if capital A is a square matrix of order n, then determinant of Ka is equal to k to the n into determinant of A. Question number 3, if capital A is a square matrix of order 2, then show that determinant of 2A is equal to 4 into determinant of A. It can be proved using this concept or by the direct method. First method 1. A is a square matrix having elements 1, 2, 4, 2, which implies 2A is the matrix having elements 1 into 2, that is equal to 2, 2 into 2, that is equal to 4, it is 8, it is 4. Whenever a scalar is multiplied with a matrix, then it will be multiplied with each element of the given matrix, which implies determinant of 2A is equal to 2 into 4, that is equal to 8, this into this minus this into this, minus 32 which is equal to minus 24. It is the LI side. 4 into determinant of A is equal to 4 into, what is the determinant of A? 1 into 2, 1 into 2 minus 2 into 4, 2 into 4, which is equal to 4, 2 minus 8, which is equal to 4 into minus 6 is equal to minus 24, which implies now we have determinant of 2A is equal to 4 into determinant of A is equal to minus 24. Therefore, determinant of 2A is equal to 4 into determinant of A. Hence proved. Method 2. Method 2. A is a square matrix of order. A is a square matrix of order 2. Implies n is equal to 2. N is equal to 2. If A is a square matrix of order n, then determinant of K A is equal to K to the n determinant of A. Here A is a square matrix of order 2, implies n is equal to 2. 2, we have to prove determinant of 2A. That means K is 2. K is also 2. N is equal to 2, K is equal to 2. We have determinant of Ka is equal to K to the power n determinant of A, which implies determinant of K means 2A, determinant of 2A is equal to 2 to the power 2, K is 2, N is also 2, which is equal to 4 into determinant of A. Therefore, determinant of 2A is equal to 4 into determinant of A. Hence proved. Clear? Next question number 4. A is a square matrix of order 3. Then show that determinant of 3a is equal to 27 determinant of a. Using this concept, we can prove question number 4. Method 1. By the direct method, that is 3a. A is equal to A is a matrix of order 3 having elements 1, 0, 1, 0, 1, 2, 0, 0, 4 is a matrix of order 3 implies n is equal to 3. We have to prove 3a is equal to 27 into determinant of 3a is equal to 27 determinant of a. Since A is a square matrix, is a square matrix of order 3 implies n is equal to 3. If A is a square matrix of order n, if A is a square matrix of order n, then determinant of Ka is equal to k to the power n determinant of A, where k is a scalar. If A is a square matrix of order n, then determinant of k is equal to k to the power n into determinant of A, where k is a scalar. Where k is a scalar. Here k is equal to 3. Since determinant of Ka is equal to k to the n into determinant of A implies k means 3. 3a is equal to k is 3. n is also 3. n is also 3 into determinant of A. That implies determinant of 3a is equal to 3 to the 3, that is 27 into determinant of A. Using this concept, we can prove question number 4, or we can prove by the direct method. Therefore, determinant of 3a is equal to 27 into determinant of A, hence proved. In method 2, we can also prove in this way. First, we will find out 3a, then its determinant. In the right hand side, first we will find out the determinant of A and multiply with the 27, so that the left hand side will be equal to right hand side. Or using this concept, we can prove the statement. Are you clear? Okay. Write down. Next, NCERT book, page number 126, part 1, exercise 4.4. Question number 4, using factors of elements, using cofactors of elements of third column, evaluate del. Solution. Using cofactors of the elements of third column. In using this column, find the value of the determinant del. Minor of yz, or it is the element of first row and third column. Minor of yz, which is denoted by M13, that is minor of first row and third column. Minor of 13 means it is the determinant deleting the first row and third column, which gives the determinant 1y 1z, which is same as z minus y. This into this minus this into this. Z minus y implies as cofactor of yz, which is denoted by A13, which is same as minus 1 to the power 1 plus 3 into minor of 13. Cofactor means minor with the proper sign is called the cofactor, which is the same as it is 1 M13, which is the same as z minus y, z minus y. Similarly, cofactor of the element zx, which is same as A, it is the element of a second row and third column, which is same as minus 1 to the power 2 plus 3 m of 2, 3. Minor of the element A23, which is same as minus M23. Deleting M23 represent the minor of the element of second row and third column. It gives minus 1 into deleting the corresponding elements of second row and third column. It gives determinant having elements deleting this row and this column. It gives 1x 1z, which is equal to minus of z minus x. Clear? It is minus 1. Minor of the element of a second row and a third column, that means it is the determinant. After deleting this row and this column, it gives 1x 1z. And cofactor of the element xy, It is the element of third row and third column A33, which is same as -1 to the power 3 plus 3 M33, which is equal to determinant of deleting the third row and the third column. Third row and the third column, it gives 1x 1y, which is equal to y minus x. Using cofactors of the elements of the third column, evaluate the determinant del. Now, del is equal to, it is the, that means expanding the third column. A13 A13 plus A23 capital A23 plus A33 capital A33. A13 is the cofactor of A13. Capital A23 represent the cofactor of A23. Similarly, capital A33 represent the cofactor of the element A33, which represent del. It is the value of the determinant del. It gives, which is same as A13 into A13, which it gives z minus y. A23, capital A23, which is equal to minus A23. A23 means A13. What is A13? It is the element of 13, yz. A23, element of a second row and the third column, that is zx. Cofactor of the element A23. Cofactor of the element A23, that is zx, which is minus z minus x plus A33. It is the element of A33, that is xy. Cofactor of A33 is y minus x. Clear? Which gives yz square minus zy square minus z square x plus zs square minus xy into x minus y. Taking minus as common, it gives yz square zy square minus z square x plus zs square. Z square taking common, this and this, y minus x. Again, z taking common, minus z, y square minus s square minus xy into x minus y, which is same as taking Taking x minus y as a common, it gives z square minus z square. It is a minus taking x minus y taking as common. It is zy plus zy minus zx minus x minus y. Taking x minus y as a common, it gives z square minus z square. Here, taking x minus y as a common, it gives x plus y. Z into y plus zx, and it is x minus y as a common, which gives minus xy. Clear? Which is same as x minus y into, taking z as a common, here z into x minus y, x minus z, z minus x minus z. Taking z as a common, x minus z, and this and this. Minus y as a common, it gives x minus z. Clear? Which is same as x minus y into x minus z into z minus y. Z minus y into x minus z, which is same as x minus y into minus of y minus z into minus z minus x, which is same as x minus y into y minus z into z minus x. Is the answer. It is the value of the determinant using the cofactors of the column 3, third column. It is the value of the determinant expanding the third column. Clear? A13, capital A13. Capital A13 represent the cofactor of the element A13. That means element of first row and the third column. Clear? Clear? Okay. Next, question number 5. If del is a determinant of order 3 and capital Aij is cofactor of small a ij, then value of the determinant del is dash. Which one is correct? We can find out the value of the determinant in 6 ways. It can be obtained expanding row 1, row 2, or row 3, or column 1, or column 2, or column 3. Value of the determinant. The value of the determinant A11, A12, A13. It must be the cofactor of the element this, but it is not the cofactor of the element A13. The cofactor of the element A small a11 is capital A11. Since it is not the cofactor of this, it is not true. Del represents the value of the determinant. A13, capital A13. Capital A13 represent the cofactor of the element 13. Small a 13. A23, capital A23. A33, capital A33. So it is not the cofactor of this. This statement is false. A11, capital A11, it is correct. But here A12, it is not the cofactor of A12. So it is false. This statement is false. This statement is also false. Since capital A21 is not the cofactor of A21, or a capital A21 is not the cofactor of the element A12. That means element of first row and second column. So it is false. Third, A21 capital A11. It is not the cofactor of the element small a21. The cofactor of A21 is capital A21. So it is false. The last one, A11, it's a cofactor. The A capital A11 is the cofactor of small a11. Capital A21 is the cofactor of A21. A capital A31 is the cofactor of A31. This represents the determinant del. This represents the determinant del. So del is equal to A11, capital A11, A21, capital A21, A31, capital A31. A11 is the element of first row and first column. It is the cofactor of the element A11. It is the expansion, it is the value of the determinant expanding column 1. A11, its cofactor is capital A11. A21, its cofactor is capital A21. A31, its cofactor is capital A31. Sum of the product of the elements of a column and its cofactor represent the value of the determinant. Sum of the product of the elements of a row or a column, sum of the product of the elements, corresponding elements, sum of the product of the corresponding elements of any row and its cofactor represent the value of the determinant. So it is the correct option. So it is the answer D, which is equal to capital D. Sum of the product of the corresponding elements of a row or column and its cofactor represent the value of the determinant. So del is the determinant, that is capital D is the correct option. So D is the answer. Clear? Clear? Okay. Write down. some important notes. Note 1. Sum of the product of respective elements of a row and cofactors of any other row of a determinant vanishes. That means 0. Or sum of the product of respective elements of a column and cofactors of any other column of a determinant vanishes. Note 1 can be verified through an example. The statement or note 1 can be verified through an example. Let del be the determinant having elements a11, a12, a13, a21, a22, a23, a31, a32 and a33. We have to prove sum of the product of respective elements of a row and cofactors of any other row of a determinant vanishes. Or sum of the product of respective elements of a column and cofactors of any other column of a determinant vanishes. Consider the first row and third row. Sum of the product of respective elements of first row and cofactor of third row vanishes. Or sum of the product of respective elements of first column and cofactor of second column vanishes. Now consider row 1 and row 3. Cofactor of A31, which is denoted by A31, is equal to -1 to the power 3 plus 1 M31, which is same as -1 to the power 3 plus 1 is 1 M31. That means minor of the element, that is third row and first column, is the determinant deleting third row and first column. Deleting third row and first column, it gives A12, A13, A22 and A23, which is same as this into this minus this into this. A12, A23 minus A13, A22. Here cofactor of the element A31 which is denoted by capital 31. Similarly, A32, that means cofactor of the element A32, which is same as -1 to the power 3 plus 1 into minor of the element, deleting the corresponding row and the column of 3A32. It gives A11, A13, A21, A23, which is equal to -1 to the power 3 plus 2, which is equal to minus A11 A23 minus A13 A21. A11 into A23 minus A21 into A13, and A33, that means cofactor of the element A33, which is same as -1 to the power 3 plus 3 into determinant of this, that is this into this, that is A11 A22 minus A12 into A21. Now to show sum of the product. Now to show sum of the product of respective elements of a row. Consider first row and third row. A11 its corresponding cofactor, that is cofactor of A31, that is equal to A31 plus A12 its corresponding cofactor in row 3, that is A12 A32 plus A13 into capital A33. Small a represent the elements and capital A represent the cofactors. To show this value is equal to 0. A11 capital A31 plus A12 capital A32 plus A13 capital A33, which is same as A11 into A31. It gives A11 into this is equal to A12 A23 minus A11 into A13 into A22 plus second A13 into A32, which gives minus A12 into this minus A11 A23. A13 A32 minus plus A12 into A13 into A21 plus A13 into A33, capital A33, A13 A11 A22 minus A13 A12 A21. The sum of the product of the elements, sum of the product of the respective elements of a row, that means first row, and cofactors of any other row, that means cofactor of a third row. Suppose it is taken as x, if it is x, A11 A12, A23. It is also X. So this is and this cancel. Minus A11, A13, A22. A11, A22 and A13. Suppose it is Y and this is minus Y. So this and this cancel. Next A12, A12, A13, it is A21. It is Z. This value is also negative of Z. So this and this cancel. So the result is 0. Hence put. Hence put. Similarly, we can prove sum of the product of respective elements of a column and cofactor of any other column of a determinant vanishes. That means 0. Clear? Clear? Okay. Next, note 2. If capital A and capital B are square matrices of order n and A is k times of B, then determinant of A is equal to k to the n determinant of B. A is equal to kb. So it is determinant of B. Where k is a scalar. Note 2 can be verified through an example. Let the statement can be verified through an example. Let B be the matrix having elements 1, 3, 2, 0. Suppose it is 0 and it is which implies this. AB is equal to, let K is taken as 2. Let K is taken as 2. If K is equal to 2, then it will be 2B which is equal to 2, 6, 0 and 4. For K is equal to 2. K is a scalar. Any scalar. Determinant of B is equal to 2 into 1, that is equal to 2, minus 0 is equal to 2. Determinant of KB. Determinant of KB, that is equal to K is taken as, K is any real number. You can take K is equal to 2 or 3 or 5 or any real number. To B is given by 2 into 4, that is equal to 8, minus 0 is equal to 8. We have to verify A mod A is equal to KB. A is equal to KB. A is equal to KB. That means 2B. A is equal to KB. Determinant of A which is equal to K is taken as 2. 2B which is equal to determinant of 2. Determinant of 2B is equal to 8. Determinant of KB or 2B is equal to 8, which is same as. We have to prove determinant of B is 2. 4 into 2 which is equal to 2 square into B mod which is equal to K is taken as 2. K is taken as 2. K is and Bj, where n is the matrix of A and B are square matrices. Order of B is equal to K to the n, which is equal to n. K to the power n is equal to 2. Determinant of B is also 2. Is equal to determinant of B is equal to this. Yes, K is 2, n is also 2, so B mod. Therefore, A mod is equal to KB, determinant, it is not read as modulus. It is read as determinant of A is equal to determinant of KB, which is equal to K is taken as 2, which is equal to K to the n into P mod is equal to 8. Determinant of A means KB is equal to 8. Clear? Determinant of A is equal to A means KB, which is equal to K to the n B. K is 2, n is equal to 2. 4 can be written as K to the power n. K is 2, n is equal to 2, which is equal to K to the n into determinant of B, that means 4 into 2, that is equal to 8. Therefore, implies this. Therefore, the statement is verified that clear. A is equal to K times of B. That means A is equal to Kp. If this condition is satisfied, if A and B are square matrices of order n and A is K times of B, A is equal to K times of B, which is equal to K means K is taken as 2, A is equal to Kb. A determinant, A is Kb, K is taken as 2, determinant of 2b, that is 2 into 4, that is 8 minus 0, 8. 8 can be written as 4 into 2, which is same as 2 square. B determinant. Determinant B is equal to 2. It is K, it is n, K to the n, determinant of B. Therefore, the statement is verified that true. Note 1, note 2 and note 3 are the short questions for 1 mark. Minor or cofactor statement. Note 3, minor or cofactor of an element Aij of a determinant of order n, where n greater than equal to 2 is a determinant of order n minus 1. Minor or cofactor of an element Aij of a determinant of order n greater than or equal to 2. The statement is true when n greater than or equal to 2 is a determinant of order n minus 1. It can be verified with an example. Let del be the determinant having elements A11, A12, A13, A21, A22, A23, A31, A32, A33. Del is a determinant of order 3. Is a determinant of order 3. Minor or cofactor of an element. Consider an element, suppose A23. Minor of the element A23, which is denoted by M23. It is the determinant of the, it is the determinant M23 is the minor of the element A23, which represents the determinant after deleting the second row and the third column. Second row and the third column of del. It gives, deleting this and this, A11, A12, A31, A32 is a determinant of deleting, after deleting the corresponding row of the element A23 and that means deleting row 2 and column 3. It gives A11, A12, A31 and A32. Clear? M23 represents the minor of the element A23, which represents the determinant after deleting the second row and third column. Second row and third column. It gives A11, A12, A31, A32. Is a determinant of order. If del is a determinant of order n, the minor of the element will be the minor or cofactor of an element Aij of a determinant of order n. It is a determinant of order 3. Minor of any element, suppose A23, its order is, what is the order of this? It is a determinant of order 2. Determinant of order 3 minus 1, that is equal to 2. Since it is a determinant of order 2, del is the determinant of order 3. Minor of A23 is a determinant of order 2. So the statement is true. For minor case, again cofactor of A23, which is denoted by A23, which is equal to minus 1 to the power 2 plus 3 M23, which is equal to minus 1 into M23 A11, A12, A31, A32 is also determinant, is a determinant of order. Del is the determinant of order 3. Cofactor of any element, that is cofactor of the element A23 is 2, that is 3 minus 1 of order 3 minus, that is equal to 2. Hence, the given statement is true. Therefore, the given statement, that is note 3, is true. minor or cofactor of an element aij of a determinant of order n, where n is greater than equal to 2, is a determinant order n minus 1. Given del is a determinant of order 3, minor of the element a 2 3 is 3 minus 1, that is 2. Here n is equal to 3. n minus 1, that is 3 minus 1 is equal to 2. Similarly, cofactor of a 2 3 is also a determinant of order n minus 1, that is 3 minus 1 is true. Hence, the statement is true. Clear? Okay. Write down.